I'm Steve Watson, the Maricopa County School Superintendent, and welcome to Engineers Week. We're once again partnering with Boeing, and we have this terrific engineering career panel where we have engineers from Boeing who are going to talk about their experiences and how they use science, technology, engineering, and math to solve problems that they deal with on a regular basis. And they're solving some very serious problems that are facing us not just here on this terrestrial Earth, but in space and beyond. And I want to give them a special shout out for taking the time to motivate and inspire our next generation of engineers that are participating and watching this panel. Let's check them out.
Hello, and thank you for joining us for a special episode of STEM Pro Live. My name is Brian Hoffner, and I'm here with an amazing panel of engineers that are joining us from Boeing that are going to tell you more about what their job is and what they're working on. So we know that there's teachers and students that are joining us from all over the country today, so I couldn't start with my normal good morning because some of you are in the afternoon. What I'd love for you to do right now is to start using that chat box and let me know where you're watching from. So what school you're at, what grade level, and what part of the state you're in. As we go through this, we have 6 different engineers that are going to tell a little bit more about their story. And if you have a question that you'd like to ask them, throw that into the chat box and we'll try to work those questions into the conversation as we're going through it. So as we get started, I'm going to start by asking a couple of my engineers to introduce themselves. I'm going to start with Elizabeth. Elizabeth.
Hi there. I think I'm unmuted now.
Yep.
All right. My name is Elizabeth Salga. I work in Florida. I work on the CST 100 Starliner, which is right here. Oh, wrong side. It's right here. We are actually launching this spacecraft from Florida, and we'll dock with the International Space Station with astronauts on our spacecraft. And then we'll come back down to land in the Western US. And actually, a fun fact is that one of our landing sites is right down the street from you guys in Wilcox, Arizona.
That's awesome. I didn't know that. Super cool. Thanks, Elizabeth. I can't wait to hear a little bit more in a little bit. Chris, where are you at?
Good afternoon or good morning to everybody. So I'm Christopher Waters, a new engineer here at the Boeing Company in Charleston, South Carolina, where I am currently a design engineer for the 787 Dreamliner, where I help design the engine nacelle and help design components that go on that engine to help make sure that they are structurally strong and things of that nature. And a fun fact about me that I just want to share with you guys that I love swimming. So all of you out there who love swimming, I'm one of you, and you can be one of me too as an engineer. So I look forward to talking more about my career as this panel goes along.
That's awesome. So, is this oceans, is this lakes, is this pools, or just anything?
A little bit of both. I was actually on my high school swim team.
Okay.
I served as a lifeguard, as my summer job. So definitely anything when it comes to water, I love.
Very cool. Well, thank you. Sierra, where are you at?
Hello, here I am. Hi, everyone. My name is Sierra Linton. I'm sitting in Baltimore, Maryland right now, but I support a team out in Long Beach, California. So we are a global company, Boeing, and we're in just about every state in the United States as well. So in addition to helping out the team in Long Beach, California, I also support a team in Oklahoma City, which is a lot of fun. And I'm a design and analysis engineer for all of the avionics systems. So I'll talk a little bit more about that later on, but that's everything in the flight deck that the pilots use to fly the planes.
Nice. Super cool. Thank you.
Yeah. And do you still want that fun fact?
Oh, I want a fun fact. Hit me with it.
All right. Well, I love music so much that I am teaching myself how to DJ right now. So that's my fun fact.
Teaching yourself. So when I teach myself, I go to YouTube. What's your go-to?
There's a little more software involved and a wide categories and different genres, but we can talk about that a little later, Brian.
I love it. I love it. Thank you. Noelia.
Hi guys. My name is Noelia Marin. I'm right now here in Washington State. My workplace is Everett, also in Washington State. I work for Boeing commercial airplanes. And I've been always working in product development. So I work on the airplanes that haven't been used yet. So it's where we design, we build, we test and certify airplanes. And a fun fact about me, I don't know. I mean, I love skiing, I love painting, music, and traveling, which is something that I cannot do right now, but I'm waiting for catching up as soon as these things gets over.
Nice. So if you love skiing, then the Northwest is a good place.
Oh, it's a great place, yeah. But
That's
COVID
awesome.
is not helping with that either. So next year it will be better. But yeah.
Nice. Very nice. Yep. Thank you. Eric.
Good morning or good afternoon, wherever you are. My name is Eric Provo, and I am a mechanical systems engineer here in Oklahoma City. I work on the KC-135 not Starliner, that was earlier, the KC-135 Strato tanker, sorry. Basically a giant flying gas station. Its job is to refuel other aircraft in flight, so they don't have to land, they can fly further, carry a heavier cargo or whatever it is they're happening to do. As a mechanical systems engineer, I'm responsible for pretty much everything that moves on the airplane. So fuel systems, hydraulics, the landing gear, air conditioning systems, any of the miscellaneous things like that, I get to play with. So a fun fact about me, unfortunately, this hobby is also kind of on hold while the pandemic situation gets resolved, but I am a big nerd and very proud of it. I love going to Comic-Cons. If you've heard of those, you know exactly what they are, but basically just big pop culture get-togethers, go with my girlfriend, friends, family members, and just have a great time being ridiculous, enjoying what we love. So.
I have to ask, do you go in costume?
Yeah, I thought that might be a follow-up.
I had to, I'm sorry.
No, I don't yet. That's hopefully going to change in the near future.
That's awesome. Very good. Thank you, Eric. Kevin.
All right. Hey, so good morning, everyone. So my name is Kevin Mixon. Here in Mesa, I've been in Mesa a year and a half. Before that was in St. Louis, but I work in the Phantom Works division, so it's research and development. And I'm currently a production engineering manager for a composite fabrication center. Before that, it was a whole host of roles in St. Louis that maybe we'll get into a little later. Fun fact is, after I graduated from my electrical engineering degree in Tennessee, oh, I thought somebody said something. After I graduated, I went back to carpentry school at night while I worked at Boeing, and then got the carpentry certificate and then started my own little small custom woodworking and home remodeling business while I was in St. Louis.
Man, that's fascinating. I love that. I love that concept of working with your hands and building those kind of things. That's great.
Oh, yeah. Thanks.
So thank you so much, panel. I can't wait to learn a little bit more about each of you and what you guys are doing, because some of you are using words that I don't understand. Like, I know Eric was talking about the two different Starliners, something that I was working on. I was like, well, I want to know more about that, because I'm thinking about if I was a student and I was sitting in school and I was thinking this might be a job that I want to pursue, I want to know a little bit more about it. So what is this type of engineer? So we're going to do just that. We're going to take some time to ask two of the engineers to come up. We're going to ask Eric and Elizabeth to rejoin us. And they've prepared a little bit of their story that they can kind of tell us a little bit more to help us understand a little bit about what their job is. So I'm going to ask Elizabeth to get started. And I think we have some visuals to kind of help support. So Elizabeth, tell us a little bit more about you.
Sure. So the type of engineer that I am is an aerospace engineer. So a lot of people will decide they want to go into engineering, and there will be something that really draws them, that you say, hey, maybe I like chemistry, so I want to be a chemical engineer and learn how to, do anything from the medical area of science, that all the way through to being an aerospace engineer, which really focuses on how planes fly and how spacecraft operate and things like that. So when I was in high school, I didn't know what I wanted to do yet, but I got inspired by space and I took a chance and I went into aerospace engineering. And I mean, I found just the perfect career for me through that. So I went to school at Georgia Tech for my undergrad and got my aerospace engineering degree there in Atlanta, Georgia. I saw some Atlanta, Georgia people on the chat earlier.
Yeah.
And then I started at Boeing full time and started on the Starliner program. Before that, I actually worked on the Space Launch System, which I think my visuals have gone away. But the Space Launch System is a really huge rocket that Boeing is building with NASA. And I also worked on some defense stuff to keep our country safe. And then I found my home on the Starliner program. So what I do at the on the Starliner is I work in mission integration, operations, and test. And what that is a fancy way of saying is I love how the spacecraft works. And I love putting astronauts inside of it. I love putting cargo and science payloads inside of it. And I like making sure that it makes it to the International Space Station and makes it home safely. So one of the jobs that I do, I'm a landing and recovery team lead. And one of the coolest jobs, and you see the pictures here, that I get to do is I jump in the spacecraft right after it lands in the desert. So the picture at the top left and the picture on the bottom are actually me inside of the Starliner right after landing OFT-1, which was our orbital flight test, and that was in December of 2019. So I jumped in and I did some testing on the vehicle. We took some cargo and gave it over to our NASA customers, so some science and different payloads, and I did that right after it landed. So it was really cool to jump into a spacecraft right after it was in space. And then I also work on a newer job, which is I work on some spacesuit stuff. So I'm just starting to get into that, but in the next couple of months, I'll be one of the leads on the spacesuit team.
That's fascinating. So these are the actual spaceships. These aren't simulators that people are practicing in. These are the actual rocket. That's so
that picture on the top right was actually we did some testing a couple years ago out in El Segundo, California, and so if you look at me in the big white suit there, that's me in a clean room garb because it was in a factory. So we have to be really clean in the factory to make sure that we don't take any dirt with us to space or any microbes or anything like that could get onto the International Space Station and cause astronauts to get sick or create FOD, which is foreign object debris that could float around. And when we're going through microgravity, could actually hurt the astronauts as we go through different G forces. So if you think about if you've ever been on a plane before, and all of a sudden you kind of feel like you're sitting really tight in your seat, that's because you've got G forces acting on you.
And a G force represents what?
So it's gravity, and it's the acceleration that gravity, the effect that it has on your body.
Okay. And I have to ask, is that Snoopy you're holding?
Yeah, so we have, going back to gravity, we have a gravity indicator. And so you'll see it on pretty much every time a human spaceflight craft goes into space, you'll see that the crew gets to choose their gravity indicator. So for us, we had Snoopy. And so once we get into zero gravity, and that's when things start floating around in space, Snoopy actually starts floating, and you can tell that you're in zero G then.
I love it. That's so cool.
And so we do have a new zero gravity indicator planned for OFT-2, but I can't tell you guys what it is. You're going to have to tune in and watch our launch. It's going to be really cool, though.
Nice. So Elizabeth, we have a question that's coming in from a 6th grade teacher here in Arizona, and it's from Marcia Carls, and they want to know, do engineers get to travel a lot?
Yeah, it just really depends on what you work on. So in my job, I'm based out of Florida, so on the Florida Space Coast. You guys have heard of Kennedy Space Center. That's where I work. And in my job, I have I do some work out in Houston, Texas, which is where Johnson Space Center is located, and that's where most of the astronauts actually live and work. And so when we're training with the astronauts, we go out there. And then like I said, I work in El Segundo, California, when we were doing testing on the spacecraft, because Boeing has these incredible spacecraft test facilities. So we actually shipped our spacecraft all the way out to California from Florida to test it there. And then I also, working on the landing and recovery team, we have landing sites in Arizona, in New Mexico, in California, and in Utah. So I actually travel out to each of those locations for training and to make sure the sites are ready for us to land there. And then we're actually going to land at some of those. So it's even cooler to think that, we could land in any of those places.
All right, we're going to have to talk offline, because the next time you're landing something, I want to be out there watching. So.
Absolutely. Well, we launch in April, on April 2nd, and we're landing either a couple days or a couple weeks after that.
That's awesome. Thank you, Elizabeth. It's super nice to meet you. Eric.
Hello. Let's see. Didn't know if I had a slide or anything.
Yep, it's coming up.
There it is. So hello again. As I said, I'm a mechanical systems engineer, but that's actually a subset of aerospace engineering in this case. Like Elizabeth, I'm also an aerospace engineer. I got my bachelor's from Oklahoma State University, Bachelor of Science in Aerospace Engineering with a minor in mathematics, and then went on to grad school at the University of Colorado, where I got a master's, also in aerospace engineering, this time focusing in bioastronautics, so human space flight, actually pretty much exactly what Elizabeth was just talking about. She's doing some really fantastic work over there. What I do right now is work on aircraft, though, and a couple of them that I've worked on are on the screen there. Currently, I work on the KC-135, the strato tanker, and like I mentioned, it's a refueling plane. It is a giant gas tank, basically, that flies 30,000 feet or higher and hooks up with multiple aircraft, sometimes multiple aircraft at the same time, to give them additional fuel, gasoline, so they can fly literally anywhere in the world, anywhere they need to go. I am on the defense side of Boeing, part of currently Boeing Global Services, which provides support, logistics support, engineering support to the United States Air Force and to a lot of our allied nations. One of them is shown on the top picture there with Australia. That's a customer that I've worked with a lot on an aircraft called the AEW&C, Airborne Early Warning and Control Platform. And that is a flying air traffic control station, basically. It is a giant radar dish, essentially, that's able to see for hundreds of miles in all directions and lets our guys see where every other aircraft is, the friendly ones from the US and some of the less than friendly ones sometimes as well, and tells our aircraft where they need to go to perform their missions. So unfortunately, I don't get as many opportunities to have pictures of myself with my work since it is on the defense side. Cameras aren't always such a good idea with some of the things that I do, but the mechanical systems aspect is really cool, and it applies to all aircraft and a lot of things beyond aircraft too. I mentioned hydraulics, but also air conditioning, flight controls. All of the systems that I work on are how the aircraft actually flies. So when you move a different part of the aircraft, moving the rudder or an aileron, elevator, how do you actually do that, and what happens to the airplane when you do that? Does it turn the nose? Does it make you climb? Does it make you descend? How do you control what speed the engine is running at? How do you get fuel to the engines? And one of the parts that I really focus on with environmental control systems is how do you keep the crew comfortable? How do you keep them alive, for one thing? Make sure they have enough oxygen, that it's a good temperature, they have a right pressure, humidity, and not just the crew, but any passengers that you have and all the electronics. If you've ever held a laptop, you know it gets pretty hot after it's been running for a while. So a lot of what I do is making sure all of the electronics on these aircraft stay cool enough that they can do their job properly and the aircraft can continue to fly safely.
That is absolutely fascinating. You see things like the Stratotanker in movies and on TV, and you never really think that this is real life, that they're actually doing this in application. So seeing a picture of that, that was super fun. I have a question that's coming in from Liliana Booker, who is a sixth grade teacher from Burge Elementary in Compton, California. And they want to know, how do they get airplanes like this into science museums because they're so big?
Very carefully is the short answer. It depends on the museum, but a lot of times the ones that you'll see in a museum are retired aircraft. They were prototypes that we used for research and development to figure out how the airplane or how the system on the airplane is going to work. And then we will, if it's big enough or if it's close enough to an airport, just fly the plane to the airport and move it into a hangar. There are some cases where you have to literally take the airplane apart and either put it on trucks or sometimes smaller aircraft and truck it through town, bring it in a door, or even take apart part of the building to get the plane inside and then reassemble it inside from there. The something a lot of people don't think about, planes are actually built to be taken apart if they have to be. The wings can be removed, the tail, the fin on the back, all of those can be taken off as part of maintenance. So it's not as destructive as it sounds to take a plane apart and bring it inside a building. It's still a big job, but they can do it.
A lot of work, but there's some purpose behind the way the thing was engineered to be built in the first place. I love it.
Absolutely.
Well, thank you both. That was awesome. I'm going to bring in two of your colleagues. I'm going to bring in Sierra and Kevin to kind of join the conversation.
Hi there. Excited to be back in the conversation.
Nice. All right. I love it. New pictures.
Yes. And while they are new pictures, these aircraft, they're very similar to the ones that Eric just mentioned. So at the top and in the bottom right, you can see another tanker plane. So this is our KC-46A tanker. And just like Eric mentioned, this is a traveling gas station. So we use that one. And then the one I have on the left is similar to the other plane that Eric just mentioned. And it's a little bit different because you can see it has a huge rotating radar protector on the top, but it has similar functionality. So then if I get into a little bit about me, I went to school in Baltimore, Maryland, Morgan State University for my bachelor's. And then for my master's, I went to University of Maryland, College Park. I studied electrical and computer engineering, but then specialized in cybersecurity. So planes like these and on the defense side really make me excited because I get to use some of that cybersecurity knowledge to make sure that we're safe and secure. So I mainly work on displays, which is why I have that top picture. So a lot of times we're taking older airplanes and bringing them into the 21st century and giving them new cockpits. So before this is the KC-46A tanker cockpit. Before we had touchscreen displays, everything had little circle analog gauges that looked like they were from 1950s and beyond. So they now have these nice new glass displays and have the same functionality or more. I also work on different displays, head-up displays that kind of allow the pilots to see what's going on outside of the windows and some of the important information they need to fly the plane at the same eye level. So rather than having to look down at these displays, they can keep their eyesight on everything else that's going on and see how to fly the plane at the same time. All right, so I also work on the commercial side, doing something similar with displays and comm radios and anything else that the pilot would need up there. And so planes that I've worked on include the 777, the 737, 787, 767, and all of the other 787s, all the sevens you can think of. All right, I will stop there.
All right, so all those sevens, do those codes have any meaning to them when we're thinking about the difference between a 747, 787, and all the 737?
Yes, they're all different airplanes. So they come in different shapes and sizes. They all still look like an airplane. So we can say similar shape, but different sizes. So some of our airplanes carry 120 passengers, and then we have some that carry 200 plus. So it's pretty cool that way. Those commercial airplanes, sometimes we transform them into freighter airplanes, which means they're used to carry cargo from here to there. We have customers like UPS and FedEx that use our airplanes strictly to carry mail across the country and beyond. So they're all different sizes, but the 7 series, they're all Boeing airplanes. So anytime you hear 707, 717, 737, that's a Boeing airplane.
Nice. So I have a question that's coming in from Carly Johnson, who is out in Oklahoma at one of the Boys and Girls Clubs. And the question, we might bring Eric back into this conversation, but it's how do those planes attach to those strata tankers in the aircraft?
Hi, Carly from Oklahoma City. That's a great question. And we can bring in Eric because he's on that mechanical side. But I can tell you it's not easy, and it takes great focus in order to line up exactly right and take one plane and line up with the next plane. So I'll have Eric go ahead and touch on that.
Thanks. And you're absolutely right. It is very tricky to make it work and to make it work safely. There's a couple of different ways that you can do it. The pictures that both of us showed were with what's called a boom system, where there's just a big rigid boom on the back of the aircraft. The plane that's getting refueled flies up really close, just a little bit behind and a little bit below the tanker. And then someone on the, there it shows it right there, that fighter that's picking up some gas. And then someone in the tanker actually controls the boom and lowers it into the receiving aircraft. There's a nozzle on the end with a very special mechanical coupler, a kind of a hook really, that fits in a socket on the fighter or bomber, tanker, whatever other aircraft it is you're refilling. And once it's made contact, there's a mechanism that locks it into place, and it tells the tanker that, okay, we have a good connection and we're ready to flow gas down to them. It's a phenomenally challenging job. The people that do it every day are extremely skilled, very, very highly trained. And it's worth pointing out too that especially on that aircraft, the KC-135, there's actually the person controlling the boom is laying on their stomach over a big window looking straight down. So if you're refueling at 30,000 feet, going 500 miles an hour with another plane just a few feet away from you, that's your view out the window. So fairly intense job, but one that they love and they're very, very good at.
Nice. Thank you for the explanation. I'm going to bring Kevin into the conversation so we can learn a little bit more about him. But I want to kind of throw something out there as a pinpoint that we're going to come back to. You guys keep approaching things saying that it's not easy, that it's tricky, that it takes skill. But every time you talk about it, you smile when you say it. And most of us don't approach problems that way. Most of us don't approach problems that are really tricky with this, okay, I'm excited mentality. It's, So we're going to spiral back to that because you guys keep bringing it up, and I think that's important to talk about with engineers. So Kevin.
Okay. All right. So mine is a little bit different. So you don't actually see any product pictures in here because majority of the work that I've done has been within Phantom Works, so it's classified. So I'll talk briefly about what I do now and then pivot back to some of the jobs that I did earlier in my career that work is exciting. You know, the work I do now as a manager, my team, they get to do all the fun stuff, and then I go to the meetings and do metrics and run charts and provide course correction. But when I first joined the company, right, I started in a group called it was the ESOs, the Integration Lab, and so what we were the last place to test the software before it went to the pilots for flight tests. And so one of the reasons that I got into engineering was because, you know, like most people that you talk to that are into engineering, is they started off with the curiosity for how things work. They take things apart, and eventually you learn how to put them back together, right? And so I fell in that same bucket. In the integration and test lab that I worked in, basically my job was to try to break the plane before it went to flight test, before a pilot or a customer broke it, because then it looks bad, right? And so I did that for a lot of years. Did weapons testing and did just overall systems integration testing, trying to break it. Canceled or not canceled, delayed, stopped a couple flight tests for issues that I found. It was just a pretty cool group or team to start out working in. Transitioned from that and went to navigations, and then it's navigations, it's CNI, communication, navigation, and identification. So on your airplanes, your radios, your GPS, and your you probably aren't as familiar. Airplanes have these things called transponders that tells the FAA, it tells them what type of plane you are. And then in the military, it has other levels where to tell other fighter pilots what type of plane you are and if you're an ally or an enemy. And the way they detect that is with an interrogator. And so it's another box that goes out, it'll ping the plane, and if you respond back with the right, know that you're friendly, and then life as well. If it responds back incorrectly or not at all, then you know there's problems. Majority of my career has been on the defense side, like others have stated. So a lot of the details you can't really get into, but I did see one of the questions where someone asked, what type of math do you use? And so it really just varies depending on what role you're in, what team you're in. When I first hired in, I did math. It wasn't super complex. It was programming and general math to test or validate systems. A majority of the work that I did was validation, making sure that the requirements were met and that the system was operating per the design. But then the team that I led just before my current assignment, we were over flight controls and wrote the control laws. And so the math that they wrote in this environment determined how this copter, how it behaved, the flight characteristics and handling qualities. And so the math in that case is a lot more intense and involved than some of the math that I was involved in at St. Louis. So it really just 100% varies depending on where you're at, what program you're supporting, and what your role is. Yeah.
Nice, that's great. I know we're getting a little short on time, so I'm going to ask Chris and Noelia to jump into, but I also saw a question that came in, and I want to kind of frame this for all of our engineers when we're closing. And it's coming from Birch Elementary, again in Compton, California, and it's what's the best part about working as an engineer? So we're going to hold that question for the end, and I'm going to ask Chris and Noelia to join us.
Hi.
And Chris, what are we looking at?
Well, we're looking at me. As you can see, I grew out my hair post-quarantine life.
As we all did.
All right. So a little facts about me is I attended Tuskegee University and got my bachelor's in mechanical engineering, which another fun fact is Boeing recently just started production on the T-7 Red Hawk, which is to honor the Tuskegee Airmen. Which is a cool fact that kind of brings home going to Tuskegee and working at Boeing, which is another reason why I love working for Boeing. So one of the neat things about working at Boeing, South Carolina as an engineer is all new engineers come into this program called the Early Career Engineer Program, which helps you learn more about your engineering discipline, and you get to see different roles within Boeing, South Carolina. So you do 4 rotations over 2 years at Boeing, South Carolina. So I started my first rotation in aft body, which is basically, if you see in the top right hand, the 787 Dreamliner, the tail third of the plane we actually make out of carbon composite material. So I help mechanics and other people who are building it build it in a safe and effective way. So if they needed, tools to help them do their job, better, that's where they came to me, and I helped, come up with different tools. Or if they needed a process enhancement, whatever that may be, I helped them in that area. And then I moved to my second position as a 787 design engineer, which is the middle picture, which is a really cool position because we help design the engine and help, or the components that go around the engine, such as the silver ring that you see me standing in, which we call the nacelle. So we help, if there's any incidents, which you guys may have seen in the news, if there's any incidents that go wrong, we take a look at these incidents and we help ensure that for the future of the components that we can design them in a more effective way to ensure their structural integrity going forward in the future. So that's a really cool position that I enjoy right now. And as you can see in that picture, these engines are massive. So that's actually one of the engines that I'm able to work on. And you see, like, I'm almost half the height of it, and it's still, it's more there. So it's really cool, to work on these massive engines and kind of get a sense of, the things that we're doing. So I really, have enjoyed my time at the company and looking forward to the next 2 rotations that I get to do in Boeing, South Carolina. And real quick, I just wanted to answer one of the questions that I saw about, do you need a BS degree or a master's? So as you can see, I only have a bachelor's right now because I just graduated in May of 2020. But one of the neat things about working for Boeing is they help finance your advanced degrees. So you don't need a master's to get your foot in the door and start working. But if that is something that you're looking forward to, Boeing will definitely help finance that for you, which is a big benefit when trying to go back to school.
Mhm.
Nice. Thank you for bringing in that question. That was a really good one that we had coming in from Nick Finger. And I'm also really glad you brought that picture into place, because the ideal of scaling and just understanding how big those engines are, like I did a double take on it a couple times. Like, that is just fascinating to see that it's really that tall and that big.
Yeah, and for reference, I'm 6'1", so these things are big.
Wow, that's crazy. That's awesome. Thank you so much. And our final panelist, Noelia.
Hi, everyone. My name is Noelia Marin. As you guys can see for my accent, I'm not from the United States. I was born and raised in Spain, and I went to college over there. When I was in high school, I just knew that I knew that I wanted to become an engineer because I love math, I love physics, chemistry, but I really didn't know what type of engineering I wanted to be. So in Spain, you basically have to decide, at least when I went to college, it's not like here that you can go and change your career while you are studying. You have to decide up front what is the thing that you want to major. And I remember being in front of my forms trying to decide, okay, there's like 20, 30 types of engineering. What should I be? Why should I choose? And I said, well, airplanes seems cool. I think I'm gonna go for airplanes, but I really didn't know much about airplanes. And in Spain, there are pretty cool places to work on airplanes, but there's not a company like Boeing where you can go and do the entire airplane, nothing like that. You can work on different areas, but not the whole thing. So if someone would have told me when I was in high school that I would be here now today, I mean, I wouldn't believe it. So when I graduated from college, there was a program, a scholarship program. My college had offered scholarships for different companies in the world, and Boeing was one of them. And I was lucky enough to get that, and that changed my life. I mean, I came here with that scholarship, and since then I've been here. I mean, and Boeing is an amazing place to work for because it's not just what you can learn over there is the amount of opportunities, different opportunities that you can have. You can work in so many different places. And I don't even know how many things you can do at Boeing. I just know my little thing here. And what I've been doing since then is working for commercial airplanes. And I've been located in Everett. You guys can see a picture of that building. So that building is the largest building in the whole world, because it's the building where the biggest airplanes that Boeing builds are done. There are line of airplanes inside there that are getting manufactured. And every day there are airplanes coming out from that building. So you can see pictures of the programs where I've been, which is another cool thing in Boeing. I mean, you don't have to work on the same thing forever. There are plenty of things that you can go and do, different projects that you can work. I've been working on the 747 LCF, which is the cool airplane that opens so it can have different pieces of the 787 that get built in different countries in the world. So they fly them to here so they can manufacture the whole airplane together. I've been working on the 747-8 freighter and intercontinental, on the Dreamliner 787s, recently on the 777, which is now being tested and hopefully will be certified in the next couple of years. And one of the things that, I mean, what I've been doing, I started as a stress analyst, doing a lot of math and physics, but I got dragged into doing more of an integration role. And I'm not very close to the airplane itself, but I have the privilege to work with many different teams. So my role basically, you guys look at these huge airplanes. I mean, although they are huge, the precision and the accuracy that you need for everything you do is not just on the calculations when you are designing or analyzing what you need to do. It's also when you are building, you are worried about just a tenth of an inch on something that is like, I don't know, 100 feet big. So all that thing, all that precision is being done by thousands of people. So the amount of integration that requires to make sure that everyone is following the same requirements, the same processes, the same schedule, so the airplane gets put together at the same time is amazing. It's a full-time job for many of us. So that's why basically I do. And what the difference from maybe 15 years ago when I started to have this type of roles until now is that the scope of integration I've been doing is bigger. So I started doing integration within one part of the airplane. I started with one of the sections of the fuselage of the 747. And now I work integration at the airplane level. So I just don't work with the structures teams. I also work with the teams, with interior teams, with the propulsion team, with the systems teams, the guys that are putting these avionics teams or the actuators or all the tubes and wires that go inside the airplane. So there are thousands of people that they need to work under the same rhythm or similar rhythm, because that also helps having a better product, a safer product, and also a cheaper product. So that's basically what I do.
I just love listening to all your stories, because even though there's a lot of crossover in some of the work you guys are doing, like you were saying, there are so many different opportunities and there's so many different ways to find your passion and to pursue it. So we have just a couple of minutes that we're going to close here. So I'm going to throw out, and Josh, if you could shift us into gallery mode so that we're all on screen. What I really want to know is, we're going to answer kind of two things. One is kind of the question that came up earlier of what's the best part about working as an engineer that Ms. Booker gave us from Compton, California. Or the follow-up question to that is, if we have students out there that are thinking this might be a job for them, this might be something that they want to do, what advice would you give them that they could start thinking about right now in their classes to prepare for a job like this? So just answer either one of those. Eric, do you want to get us started?
Sure. So I'll start with the second one, actually. If you're thinking about getting into engineering, what should you do? Keep thinking about it, for one thing. Don't lose interest. It's a lot of fun. it is a challenge. It is difficult. The work that we do is very demanding, but it's worth it. We get to do really cool things. We make things that fly around the world or above the world. If you're doing spacecraft, go to other worlds for spacecraft. So if it's something that interests you, keep staying in school, studying what is really a major interest to you. If it's science, great. If it's math, great. Whatever you're passionate about, keep focusing on that. And one thing I would absolutely say is don't get discouraged if something is hard. There's always going to be something hard. You're not the only one that's struggling with it, but find someone that can help you through it. Um, the math that we use, the science, all of that, again, it is challenging, but the rewards more than pay for it. As you work your way through it, you learn, you get better, you become a better engineer, a better person, hopefully too, and you have a lot of fun and hopefully make the world a better place at the same time. So that's what we all try to do, I think.
I see a lot of head nodding there. A lot of people in agreement there. Noelia, do you want to build on that or respond?
Well, I totally agree with what Eric said. I mean, it's tough, but if you like it, it's not so tough because you like it, and you just need to be patient about it. And it can be this, or it can be some other thing. But it's. I mean, I find a lot of satisfaction in becoming an engineer or using or apply math or that logical thinking that when you study to become an engineer, also it's not just the application of what you learn, but also it makes you think in a logical way that is something that you can use for anything, not just for working. It's also for your personal life to understand some other things better. And plus math is the only thing that is always predictable, you know, always 2 + 2 is always 4, which doesn't happen anywhere else. So I personally like it. It's tough. It can be tough, but you learn a lot. And as Eric, I mean, when you make mistakes, you also learn from them and you become better. And you don't have to know it all. Again, no one is knowing. I mean, no one is going to be able to know all. We need hundreds of people to make this together.
You guys keep saying hard things and tough things, and you all smile and start nodding. I don't know what's engineers are different. Kevin, what do you got for us?
Yeah, with the smile though, you know, that's the old hindsight is 2020 type of deal. You know? In the midst of the problem, there's no smiles. There may be a few forced ones, but afterwards, when you look back,
gotcha.
You know, you appreciate the path to get there. I mean, in general, you know, like on the defense side, it's a little like I can't talk about all the cool and awesome projects that I've worked on between PhantomWorks and BR&T, but some of the things that we're doing and creating are, I mean, it's like, no kidding, it'll change the world. Like, it's amazing some of the products that are out there that people have no clue are there, and things you get to work on and be a part of. Some of the things happen, some of the things don't. I was on a next gen attack helicopter program, which was great, but you know, we weren't down selected. So such is life, right? Ups and downs. But in general, you know, you go to school, it prepares you to start, and then once you get into the company, you learn on the job. You work with a lot of SMEs, a lot of leaders, a lot of great and capable people who help fill in the gaps for what you don't know to be successful in whatever role you're undertaking or responsible for. Yeah.
So I think there's something resonating with our audience. Nick Finger, who's a teacher out in Portland, Oregon, just said we can do hard things. So I think they're connecting with part of the story here. Sierra, what advice would you have for our students?
Yes, I agree. Those are the same reasons why I love engineering. But for these students, I say keep going, challenge yourself in school. So take the harder classes and just give it your all to do learning the right way. Because when you learn how to learn the right way and think the right way, which is solving tough, challenging problems, you'll be able to do engineering and anything else you put your mind to. So always go for the harder problem, because the reward is better that way.
Nice. Elizabeth.
Yeah, I think everything that you guys have said is so on point. I think one of the coolest things about working in engineering in general is that, like you guys said, we're always working in a team. You know, when you're going through school, you're doing your tests by yourself usually, and so it sometimes it feels like if you don't know everything that you're going to fail, because that's how it feels on an exam. But when you actually get into work, you're working on these massive teams or small teams, and you're supporting each other, and you're helping each other learn and helping each other create the best product, the safest operation, whatever it is. I mean, I work with, you know, engineers from all across the country. And then I also work with, you know, EMTs and, you know, firefighters in some of my jobs. I work with people who do search and rescue. So all kinds of teams that I never thought I'd work with, and that are part of solving this problem together. And I think the biggest thing is, back to what Noelia said, you know, you're learning how to think when you become an engineer. You're learning how to approach problems. And I'm actually, speaking of EMTs, I forgot my fun fact earlier, but I'm studying to become an emergency medical technician in my free time. And it's really funny because whenever I'm, you know, doing training in class, they're always saying, oh, that's the engineer, she thinks different, you know, because they can see that the way that I'm approaching problems, it has been shaped by me being an engineer. I'm always thinking about what could go wrong, or what's a different way to think about this, or how can I put this in a system so that, you know, I can remember it and put it into action next time really quickly. So I think my engineering has helped me, you know, do something like that. Or even when I'm scuba diving and I'm thinking about how, you know, the oxygen and the nitrogen work in your body and all that kind of stuff, it all comes into play. And me being an engineer doesn't mean, you know, that's not the only way to become a scuba diver. So it's just a piece of how I think now.
That's amazing. Once you get your EMT cert, we'll have Sierra DJ your party. You'll probably finish at the same time. All right, Chris, bring us home. What advice would you have for us, or what do you love most?
Yeah, that's tough because everybody said, you know, great information, but I think one thing that I wanted to add on to you guys that are, you know, potentially seeking engineers and trying to figure out, you know, how do you know if engineering is for you? I would just say simply continue taking opportunities like this to, you know, learn from different people and different engineers, because when I was in third grade, I thought I was going to be a police officer or a firefighter, like most little boys did at that time. But, you know, now I'm an engineer, and that came through taking different opportunities. So really the one pivotal one for me was in high school when I joined the robotics team, and it kind of helped, you know, help me learn about robotics and also computer science and programming, and just introduced me. And then when I went to college, took different internship opportunities to help, you know, figure out what engineering I did like. And it's funny enough that I now volunteer with the high school robotics. So I see the teacher, Roy Kemp, who I helped his high school and mentor them. So it's like, I think the biggest key in figuring out what you want to do in life, whether that's engineering or some other field in math or science or whatever it be, is just take the opportunity to learn and see different insights of different people, because they'll help guide you and you'll help see what you like and what you don't like. And what I tell a lot of people, what you don't like is often more important because it drives you to what you're passionate about and what you truly enjoy. So that would be my advice if I had to give some to you guys.
Mhm.
So Miss Sandra Abbott, who is a teacher out at Echo Canyon here in Arizona, math and reading teacher for 4th and 5th graders, she made the comment that it's team effort. It's a team effort. And I think she was responding to Elizabeth talking about that. And you guys are such an amazing representation of the teams that are there at Boeing, and you're so inspirational. We thank you so much for taking the time to let our students know that the word engineer, it's not just, you know, this scary thing that you don't really know what it is. Like, these are the people that are behind it. And you guys' story is so relatable and so inspiring. I'm just super excited that our students got the opportunity to hear this from you. So thank you so much for taking this time.
Thank you for having us.
Yes, thank you very much.
So, and all of my
Good
students
luck
and
to you
teachers
all.
that are out there, we thank you for taking the time to tune in and for asking all your questions and for showing up in our chat box. We have one more opportunity this week where you can meet with 2 final engineers from Boeing, and they do something a little bit different as they're working under the oceans. And so we haven't had that experience yet as we've been talking to the engineers on this panel. So we're going to go into a completely different realm as we're learning about what they're doing under the sea and under the oceans with their exploration there. So please register and join us this Friday at 10 a.m. for our last challenge panel, where we're going to talk about what it means to think like an engineer. What does that mean when you're going through the design thinking process and coming up with solutions to these tough problems? So taking this mindset of smiling, even if it's after the fact, when you're learning how to design these solutions. So thank you so much for joining us. We'll see you next time with STEM Pro Live.